This lesson deals with supplemental problem 9.2. You can find this problem in the ECE202 ebook in the Chapter 9 Supplemental Problems on page 2. In our last supplemental problem, we looked at a delayed ramp. So let's find the Laplace transform of t times u of t minus a, where a is greater than 0. Let's apply our definition of a Laplace transform. We'll take the integral from 0 minus to infinity of our function, which is t times u of t minus a, and then multiply that by e to the minus st dt. U of t minus a, the value of this is 0 for t less than a. So we can do our integration then from 0 minus to a, and then from a to infinity. The value from 0 minus to a would be equal to 0. We're left with then the integral from a to infinity of t times e to the minus st dt. I want to get this limit here to go back to 0. So let's do a change in variable. Let's let tau equal t minus a. Then the derivative of tau with respect to t is just equal to 1 minus 0. So then d tau is equal to dt. Let's fix up our integration limits. So when t is equal to a, then tau is equal to a minus a, or 0. And then when t is equal to infinity, tau is equal to infinity minus a, which is just infinity. So our integral then from a to infinity of t e to the minus st dt can be rewritten then as the integral from 0 to infinity of t replaced by tau plus a, and then e to the minus s t replaced by tau plus a, and then dt is the same as d tau. Multiply this out, I've got e to the minus s tau times e to the minus sa. Now this is not a function of tau, so I can bring it out in front, and I'm left with then the integral from 0 to infinity of tau times e to the s tau d tau, and then also I got a times e to the s tau times d tau. Separate those two terms out. Now a is not a function of tau, so I can bring that out in front. I was replacing t by tau. This is our Laplace transform of 1 over s squared, and this is a Laplace transform of just a over s. So then our results then are e to the minus as times 1 over s squared plus a over s. This is supplemental problem 9.2.